Welcome, and today we're going to do Chapter 9, Lesson 8, Choosing the Best Representation of Data. So far we've been studying all these different types of graphs, and today's objective is you'll be able to select the best type of graph to use to represent data. An important point I want to get across in this lesson is that data can be represented in several different ways, and it really depends on both on the type of data and then also the message that you want to convey. We'll start with a line graph. A line graph is really good. It's really good at showing change over time. And just a quick visual is when you look at a line graph, you go left to right and you can kind of see a story, kind of like we did in the other lesson, telling the story of what was happening. Now a bar graph, on the other hand, that is good at showing relationships or comparisons between groups. And remember, we talked about bar graphs are good for categories. A circle graph, which we made, that compares parts of a whole. So if there's a whole amount involved, then you want to do the circle graph. What I did quickly is highlighted the important words that will help you realize what graph to use. So line graph, change over time. Bar graph, comparisons between groups or categories. And then circle graphs are just like the main word is whole, you know, the whole amount. Frequency, histograms. We've studied histograms, and the main word there is frequency. And also divided into equal groups, we call them intervals. Scatter plot was good at showing a relationship between two data sets. And line plot shows the frequency of data, so might be confused with histogram, might be hard to distinguish. Stem and leaf, that shows how often data values occur and how they are distributed. So these are everything I highlighted are good indicators of which graph would be the best for that situation. I want you to take a look at this graph here on the left, and why is the line graph a better representation of this data than a bar graph? So look back at our notes, and what was a line graph's underlined word? What did I underline? And I underlined change over time. And what is this graph showing? Well, it's showing change, and it's over time, over months. So it's perfectly matched. And then a bar graph would be more for categories. And I know months are, maybe you could say they're categories, but really months are a measurement of time. And like I said before, the viewer of the graph gets a story. You can tell, boy, not many people visited twitter.com, and then all of a sudden, boom, in January 09 or February 09, all of a sudden, boom, it just starts taking off after that. So good visual. Here we have students at PS 124 in Queens, Public School 124, outperform their peers citywide. So here's our graph. And why is this bar graph a better representation of data than a scatter plot? So go back to your notes. Bar graph is really good at what? Categories. And we have our categories are kind of our grades, okay? And then also the public school 124 versus New York City. And what they really are showing comparisons. Now a scatter plot, it does compare data between two groups, but a scatter plot is good at comparing data that sometimes overlaps or kind of doesn't have a set pattern. It's all over the place and you're trying to look to see a pattern. Here we're really just comparing two quantities at each grade level. So our categories, and it's two things at each grade level. So very good representation. Who won in 3rd grade, who won in 4th grade, and so on. All right, the Vikings, when they used to have Brett Favre, the good old days. Why is this double line graph a better display of data than a bar graph or a scatter plot? Well, okay, line graph is really good at, come on, showing change over time. And this is the course of the season. These are the games the Vikings played in order that season. And you can tell the pass attempts, how they went up and down during the season. You could tell the rushing attempts, that means running instead of passing attempts. So it gives the viewer a really good picture of, did they vary? It looks like they varied. And did they stay consistent? And when the passing was up, it looks like the rushing was down, and you can see that pattern. Where a bar graph would be more categories, and scatterplot again compares two sets of data, which this is, but scatterplot is more just doing a bunch of dots and looking for a pattern. Okay, this is kind of a check to see how we're doing. Here I have a little cheat sheet of the notes, and I want to see if you can choose the best data display for each situation and then explain your choice. So, number 1, how Mr. Malone, he's a social studies teacher at CMS, how he spent his time on Monday. Well, the first thing that your brain might think of is, time. I'm thinking a line graph. But be careful there. I don't think how he spent his time is going to be categories. And really, Monday is a whole day or a whole school day. So because we're dealing with a whole, let's look at our chart and find out which one's good at the whole amount. And that would be right here, circle graph. So like I said, circle graph, because it would show how he spent the parts of his whole day, his entire Monday. How about number 2, the price of Carlos stock over 1 week? Okay, prices of stocks can change, and over 1 week is change over time. So remember, which one is good at change over time? Okay, remember those key words, time and change. So a line graph would be very good for number 2. All right, number 3, the points scored by a football team during each game of a 16-game season. So I'm thinking about this one. I know it's over time, so you could go a line graph, but really, I look here at line plot or stem and leaf plot, because a line plot's going to show the frequency of data, so how frequent did they score, but then stem and leaf too shows how often the values occur and how often they're distributive or how they are distributed. So the points scored during each game of the 16-game season, you could see how that progressed. I'm not going to be able to fit this all in here, but again, what it would do is using line plot or stem and leaf, each point total would be shown. You'd be able to see each point total. It would be listed. And then you could see the frequency of the data. You would also see how it's distributed. Number 4, comparison of people's shoe sizes and their age. So this has come up before. So think about that one. What would be a good graph for that? A good one there would be scatter plot. And it's because, these are kind of two different things, shoe size, age. And when you pick two things that are different, a scatter plot is a good way to see, is there something that some relationship or correlation they have between each other? Is there something that one of them affects the other by? So scatter plot would be good. And we would be able to see the relationship between these two data sets, between shoe sizes and ages. Lastly, the distribution and range of student scores on a history exam. Well, look at our choices. histogram, that would show the frequency of data divided into equal groups, so we could see the groups and how they did. Another good one would be line plot, because that's going to show the frequency. How often do kids get A's or B's or C's or 90s or 80s. So like I said, histogram would show us the frequency, like how many were in the B range on that test or exam, and then line plot too, frequency. Like you could say, well, I could see how many kids actually got a 78% because there'd be maybe 5 X's at the 78%. So these are all good, and they're not always black and white, but again, keep these keywords in mind when you make your choice, so that you'll be able to defend your choice. Do the practice problems and bring any questions you have to class tomorrow.